Hey everybody. Today we're talking about statistical sampling. Let's get started with a piece of contrasting terminology. A census is complete data for an entire population. While you really want that kind of data, you typically don't have access to it. It's just not possible or practical. A couple of examples to illustrate that problem. Is a new medication effective in reducing cholesterol in a certain group of patients? Well, we would like to know if the medication's effective in all patients, but first we have to test it. In order to do that, we're just going to use a random sample. Second, what percentage of voters approve of the way the President of the United States is doing their job? So there's a lot of voters. Contacting them all is an expensive and time-consuming proposition. If nothing else, by the time you get to the last one, the first one probably has changed their mind. So the common solution to this is to gather a sample from that population and then try and draw conclusions about the population from the information you have about the sample. There are lots of ways of gathering a sample. Some are better than others. Let's start out with a couple of ways of gathering data that you should be skeptical of. First, anecdotal evidence. And that's just personal testimonials that are given by individuals that you happen to come in contact with. You'll hear statements like, well, this medication worked for everyone in my family, or everyone I've talked to lately approves of the president. Another thing to watch out for is convenience sampling. And this consists of data that's collected just because it's easily accessible, like a political poll that's taken outside a nearby park, or a psychological study whose subjects are just college students at that same college. In each of those cases, the sample is likely to be different from the population in important ways. It's going to result in statistics that are different from the corresponding parameters. This is called bias in the statistical sense. For instance, a convenience sample of college students may react very differently in a psychology experiment than older individuals. The normal way to gather a sample when you can is through random sampling. And that just means that a random process is used to determine which members of the population are included in the sample. And typically, all members of the population have an equal chance of being selected. That's not always the case. The point of random sampling is to avoid that sampling bias, in which statistics are either higher or lower than the corresponding parameters on average. Now, statistics derived from random samples are still variable, even if they're unbiased, in the sense that each time you go out and run the study, you're going to probably get a different statistic every time. This is not a form of bias because, on average, the statistic will still hit the parameter value exactly. Now, there are many different kinds of random samples, and the most basic is the simple random sample, often abbreviated SRS. And this is one in which every sample of the same size has an equal chance of being selected. Now, your intuition might be that every individual has an equal chance of being selected, but there are actually many different ways of doing that. That intuition is okay, but don't deal with it mathematically in that sense. A simple random sample is one in which every sample of the same size has an equal chance of being selected. Another important sort of random sample is the stratified sample. And in this situation, the population is first divided into groups, strata, according to some important characteristic like age, sex, or race. And then we go out and we get a simple random sample from each one of those groups. And this ensures that we get representation across ages, across sexes, across races. Now, often in a stratified sample, every individual has an equal chance of being selected, but not all samples are equally likely. For instance, if we're stratifying by sex, we are going to get a certain number of men and a certain number of women. It's impossible in that situation to get a sample of all men. Related but very different is a cluster sample, in which a population is divided into similar groups, usually naturally occurring ones, and then a simple random sample of the clusters is taken. And then every member of the cluster is included in the sample. So in this situation, we're randomizing, but it is at the group level. So we divide things up just as we did with stratified random samples, but now instead of randomizing at the individual level in every group, we randomize among the groups and just take some of those. Finally, a multi-stage sample combines those last two techniques. We make some strata or clusters. We do that, we take some of them at random, and then instead of looking at everyone within each cluster, we take a simple random sample from each. And it's possible to repeat that process, having groups within groups. One other sampling method that's worth mentioning, even though it's not random, is the systematic sample. And in a systematic sample, members of the population are chosen in some predetermined way. For instance, you might stand outside a grocery store and ask every 20th person who exits about their experience in the store. And that's not a random sample, but it ends up having the sort of same effect because the people coming out of the store don't have any particular pattern to them. There's no reason to think the 20th person will be any different than the 19th or the 21st. All right, let's do a few examples. In each case, I recommend pausing the video, trying to come up with an answer, and then unpausing the video to hear my answer and my reasons for it. So in each case, identify the sampling method described. Number 1, a pollster contacts 400 men and 400 women, asking each whom they support in an upcoming election. So this is a stratified sample. We have divided the population into 2 groups, men and women, and then taken a random sample from each. Researchers select 50 high schools at random, then give a math proficiency exam to every student at those schools. So this is a cluster sample. We've taken all of the possible high schools in question and then just picked 50 at random and then studied everyone at each of those schools. And this is a good example of a place where a cluster sample is a desirable thing. It's not going to be possible to get a simple random sample of all high school math students in the country. And it's also not possible to go to every high school and take a random sample within each one. So neither a simple random nor a stratified random sample is going to be desirable here. On the other hand, a cluster sample is very practical. A car dealership uses a customer list to randomly select 200 previous car buyers, and then they contact each one with a satisfaction survey. So this is a simple random sample. They have a list of the population, all of the people they've sold cars to. They take 200 at random and survey them. Next, in a security checkpoint, every 20th person is pulled aside for extra screening. So this is a classic example of a systematic sample. It's not random, but there's not any reason to think the 20th person would be any different from the 19th or 21st. So it has much the same effect from the sampling perspective. Finally, a medical group randomly chooses 35 U.S. hospitals. They then sample 50 patients at each, examining the cost of their care. So this is a classic example of a multi-stage sample. We are dividing the population up into groups, that is, the different hospitals, and then we are randomizing both which hospitals, which groups we look at, as well as which individuals, which patients we look at within each one of those groups.